Tonight, as Earth quietly spins beneath the stars, let your mind drift toward a distant world that has fascinated dreamers, scientists, and explorers for thousands of years. A silent red planet hangs in the darkness, glowing softly against the black sky, keeping secrets that no human has ever fully uncovered. Mars has inspired myths of ancient civilizations, stories of alien worlds, and decades of scientific exploration. Yet despite everything we've learned, one question continues to echo through laboratories, observatories, and the imagination of millions. Could life exist on Mars? Perhaps tiny microbes once lived beneath its ancient rivers. Perhaps life still hides deep underground, protected from deadly radiation. Or perhaps Mars is simply a beautiful reminder of what happens when a once-living world slowly falls silent. Tonight, we won't rush toward answers. Instead, we'll travel slowly across endless deserts of crimson dust, climb the tallest volcano in the solar system, wander through valleys carved by ancient water, and watch gentle blue sunsets beneath a thin pink sky. Every discovery will bring another mystery. Every mystery will lead to another quiet question. So settle into your bed, relax your shoulders, take a slow deep breath, and allow the universe to unfold one peaceful story at a time. Dim the lights if they're still on, close your eyes whenever they begin to feel heavy, and let the calm rhythm of science gently carry you towards sleep. Our journey begins nearly 225 million kilometers from home, on a lonely world where every grain of dust whispers the possibility that we may not be alone. The red planet has watched over humanity for as long as people have looked toward the night sky. Long before telescopes existed, Mars appeared as a bright reddish point of light wandering slowly among the stars. Ancient civilizations noticed that it moved differently from the fixed constellations, almost as though it had a purpose of its own. They did not know they were watching another world. To them, it was a mysterious traveler crossing the heavens. Its deep red color inspired countless stories. Some imagined it as a symbol of war because it resembled the color of blood. Others believed it carried messages from the gods. Every culture added another layer to the mystery, creating legends that survived for thousands of years. Tonight, however, we leave those ancient stories behind and look at Mars through the gentle lens of modern science. Surprisingly, the real planet is even more fascinating than the myths. If you could quietly float through space toward Mars, you would first notice how peaceful it appears. At first, Mars might seem familiar. It has seasons, polar ice caps, clouds, valleys, mountains, and even weather. Yet the closer you come, the more you realize that this is a world shaped by very different rules. Its atmosphere is astonishingly thin. If you could somehow step outside without protection, you would quickly discover there is almost no breathable oxygen. The air is made mostly of carbon dioxide, with only tiny traces of oxygen and water vapor. The pressure is so low that liquid water struggles to exist on the surface for long. Instead of forming flowing rivers as it does on Earth, water would often freeze into ice or disappear directly into vapor. This alone makes Mars feel both familiar and strangely alien. The ground beneath your feet would not be gray like the moon or green like Earth's forests. Instead, it would stretch endlessly in shades of reddish dust. That famous color comes from iron minerals scattered across the planet. Over millions of years, those minerals reacted with oxygen, creating rust. In many ways, Mars is covered by billions upon billions of tiny grains of rust, giving it the appearance of a planet painted in warm red tones. Gentle winds lift this fine dust into the atmosphere every single day. Small whirlwinds, called dust devils, quietly wander across the plains, twisting like invisible dancers beneath the pale sky. Some leave dark tracks that satellites can see from orbit, silently recording where the winds have passed. The sky itself would surprise you. Here on Earth, we are used to brilliant blue afternoons. Mars offers something completely different. During the day, the sky often appears soft pink, pale orange, or butterscotch because tiny dust particles scatter the sunlight in unusual ways. As evening approaches, another remarkable sight appears. While sunsets on Earth usually glow red and orange, sunsets on Mars often shine with delicate shades of blue surrounding the setting sun. It is one of the few places in the solar system where sunset colors seem almost reversed. Imagine standing alone on an endless plain, watching a small blue sunset slowly fade into darkness. No birds sing. No leaves rustle. No ocean waves roll onto distant shores. Only silence. The quiet on Mars is unlike anything we experience on Earth. Without thick air to carry sound efficiently, the landscape feels almost frozen in time. Every distant noise becomes softer. Every movement seems slower. The entire planet rests beneath an enormous blanket of stillness. That peaceful silence is one reason Mars captures the imagination so deeply. It is not simply another planet. It is a place where time itself seems to move more gently. Yet despite its calm appearance, Mars was not always so cold and dry. Billions of years ago, this lonely world may have looked dramatically different. Scientists studying ancient rocks, river channels, and mineral deposits have found evidence suggesting that water once flowed across the surface. Vast rivers may have crossed enormous valleys. Lakes may have reflected the sunlight. Perhaps even shallow seas stretched across parts of the northern hemisphere. If that picture is true, then Mars once possessed one of the most important ingredients for life as we understand it: water. Wherever liquid water exists on Earth, life finds a way to survive. Tiny microbes live deep beneath rocks, inside frozen glaciers, around boiling volcanic springs, and even within some of the harshest deserts on our planet. This naturally leads to one of the greatest scientific questions ever asked. If ancient Mars had rivers, lakes, rain, and perhaps even oceans, did life ever begin there? The answer remains hidden beneath layers of ancient dust, waiting patiently for curious minds to uncover its story. For a very long time, Mars may have been a world that looked surprisingly familiar. If you could travel back more than 4 billion years, the planet before you might not resemble the frozen desert we know today. Instead of endless fields of dust, there could have been flowing rivers winding through broad valleys, lakes quietly reflecting the pale sun, and perhaps even a vast northern ocean stretching toward the horizon. The sky would still have looked different from Earth's, but it may have been much thicker than it is today. Clouds could have drifted overhead, carrying moisture across the landscape. Gentle rain may have fallen onto rocky hillsides, feeding streams that slowly carved the surface. This vision of ancient Mars is not simply imagination. Orbiting spacecraft have mapped enormous channels that resemble dried-up riverbeds. They twist and branch just like rivers on Earth, following the natural curves of the land. Some extend for hundreds of kilometers, suggesting that water once flowed across the planet for incredibly long periods. Other regions contain smooth, rounded pebbles. Here on Earth, rocks become rounded after tumbling through moving water over many years. Sharp edges gradually disappear as rivers gently polish them again and again. When robotic explorers discovered similar stones on Mars, scientists became quietly excited. It was another clue that water had once shaped this distant world. Certain minerals found across the Martian surface tell an equally remarkable story. Clay minerals, for example, usually form when rock remains in contact with liquid water for long periods. Their presence suggests that some parts of Mars stayed wet not for days or weeks, but perhaps for thousands or even millions of years. Imagine standing beside one of those ancient lakes. The breeze would be cool. Small waves might gently ripple across the water. The surrounding hills would cast long shadows during the evening, while the fading sunlight painted the landscape with soft golden colors. It is a peaceful picture. Yet beneath its beauty lies an extraordinary question. If water remained on Mars for such long stretches of time, could tiny living organisms have appeared there? Scientists often begin their search for life by asking a simple question. Where can water exist? On Earth, life seems almost impossible to separate from water. From microscopic bacteria hidden inside Antarctic ice to strange creatures living near volcanic vents thousands of meters beneath the sea, every known living thing depends upon it. Some organisms survive temperatures far below freezing. Others flourish in water hot enough to boil. Some live in complete darkness without sunlight. Others survive inside highly acidic lakes where most forms of life would quickly perish. These remarkable creatures remind us that life is astonishingly adaptable. Perhaps much more adaptable than people once believed. This realization changed how scientists viewed Mars. Instead of asking whether Mars looked exactly like Earth, they began asking something different. Could Mars have offered just enough of the right conditions for microscopic life? The answer remains uncertain. No spacecraft has ever discovered undeniable evidence of living organisms on Mars. Not yet. But every mission uncovers another piece of the puzzle. Some discoveries make the mystery even deeper. One of the greatest surprises came when scientists realized that water has not completely disappeared from Mars. Frozen water still exists today. The brilliant white polar caps are made partly of water ice and partly of frozen carbon dioxide, often called dry ice. During the changing seasons, these icy caps grow and shrink as temperatures rise and fall. Even beneath the dusty ground, hidden reservoirs of frozen water stretch across large areas of the planet. Some estimates suggest that if all this underground ice melted, it could cover much of Mars with a shallow ocean. That thought is astonishing. Beneath one of the driest places in the solar system lies an enormous supply of frozen water waiting silently beneath the surface. Scientists have also found mysterious dark streaks appearing on steep slopes during warmer seasons. For a time, many researchers wondered whether these markings were caused by salty liquid water briefly flowing downhill before disappearing again. Later studies suggested they may instead be created by shifting sand and dust. Even so, the question remains open enough to encourage further exploration. Mars rarely provides simple answers. Every discovery seems to replace one mystery with another. Perhaps that is why the planet has fascinated generations of explorers. Even from millions of kilometers away, it refuses to reveal all of its secrets. As the years passed, scientists began asking an even larger question. If Mars once possessed rivers, lakes, and perhaps oceans, what happened? Why did such a promising world become so cold, so dry, and so quiet? The answer may lie deep inside the planet itself. Long ago, Mars likely possessed a powerful magnetic field similar to Earth's. Our own planet is protected by this invisible shield, which deflects many charged particles streaming outward from the Sun. Without that protection, the solar wind would slowly strip away Earth's atmosphere. Scientists believe this is exactly what happened to Mars. As its interior gradually cooled, the planet's magnetic field weakened and eventually disappeared. Without that invisible shield, energetic particles from the Sun began colliding with the upper atmosphere. Year after year, century after century, million after million years. The atmosphere slowly escaped into space. As the air became thinner, temperatures fell. Liquid water became increasingly unstable. Rivers dried. Lakes vanished. Oceans may have frozen or escaped into space, while much of the remaining water became trapped beneath the ground as ice. Mars slowly transformed into the quiet desert we see today. Standing there now, you would witness a world shaped by incredible change. Ancient shorelines hidden beneath dust. Dry river valleys stretching beyond the horizon. Mountains older than almost anything on Earth. Frozen water sleeping beneath the surface. And somewhere within those ancient rocks, perhaps, the smallest traces of a story that has yet to be discovered. The search continues, not because scientists already know the answer, but because Mars keeps whispering that one more secret may still be waiting just beyond the next horizon. As our quiet journey continues across the red planet, the landscape begins to change once again. Far ahead, rising from the dusty horizon, stands a mountain so enormous that it almost seems impossible. At first, it appears like a distant cloud touching the sky. But as we slowly move closer, its true size becomes difficult for the human mind to imagine. This is Olympus Mons. Not simply the tallest mountain on Mars. The tallest volcano ever discovered anywhere in our solar system. From its base to its summit, Olympus Mons rises nearly 22 kilometers into the Martian sky. If it stood on Earth, its peak would reach far above the cruising altitude of many commercial airplanes. Its base stretches across hundreds of kilometers, covering an area nearly the size of an entire country. Standing near its slopes, you might not even realize you were looking at a mountain. One reason Olympus Mons became so enormous is that Mars has weaker gravity than Earth. Gravity on Mars is only about 38% as strong as Earth's. A person weighing 70 kilograms on Earth would feel as though they weighed only about 27 kilograms on Mars. Every step would become lighter. Every jump would carry you higher. Even a simple walk would feel strangely graceful, almost like moving through a dream. This lower gravity also allowed gigantic volcanoes to grow without collapsing under their own weight. Earth's stronger gravity limits how tall mountains can become. Mars places fewer restrictions on such giants. For millions of years, Olympus Mons continued to grow. Today, it rests in complete silence. No glowing lava pours from its summit. No clouds of volcanic ash rise into the sky. The volcano sleeps beneath layers of ancient dust, preserving a record of Mars' distant past. Not far away lies another remarkable volcanic region known as Tharsis. Here, several giant volcanoes stand together like ancient guardians watching over the surrounding plains. Their massive shapes remind us that Mars was once a geologically active world. Deep beneath its surface, molten rock moved, pressure built, and volcanic eruptions reshaped entire continents. Those fiery days are believed to be mostly over now. Yet their legacy remains written across the planet. As we continue our peaceful flight, another extraordinary feature comes into view. A canyon begins to appear. Then another. And another. Soon the ground seems to split apart beneath us. This is Valles Marineris. Calling it a canyon almost feels unfair. It is more like an entire network of enormous valleys stretching across Mars. If placed on Earth, it would extend across a distance greater than the width of the United States. Some sections reach depths of nearly 7 kilometers. The cliffs plunge downward into darkness, revealing layers of rock that have remained untouched for billions of years. Scientists believe these exposed layers are like pages inside an ancient history book. Each layer preserves evidence of changing climates, volcanic activity, floods, and perhaps even environments where life could once have existed. If future astronauts explore these cliffs, they may discover answers hidden within rocks older than almost every landscape on Earth. The canyon itself may not have been carved primarily by rivers. Instead, much of it appears to have formed as the Martian crust stretched and cracked. Imagine the surface slowly pulling apart over unimaginable lengths of time. Great fractures opened. The ground sank. Gigantic walls rose on either side. Later, water, landslides, and wind continued shaping the landscape into the breathtaking canyon system we observe today. Even after billions of years, Mars is still telling its story through stone. The planet speaks without words. Every crater, every cliff, every valley, every grain of dust. Each one preserves another chapter of a history that began long before Earth was home to forests, dinosaurs, or even complex life. Time itself feels different on Mars. Because there is very little rain, almost no flowing rivers, and much less geological activity than on Earth, ancient features remain visible for astonishingly long periods. On our own planet, mountains slowly erode. Rivers reshape valleys. Plants cover rocks. Earth constantly renews itself. Mars changes much more slowly. Some landscapes visible today have remained almost unchanged for billions of years. Walking across its surface would feel like stepping directly into the distant past of our solar system. The quiet is overwhelming. The air is thin. The wind whispers softly across endless plains. Tiny dust particles drift through the pale sunlight. Nothing seems rushed. Nothing interrupts the silence. It is almost as though the planet has been patiently waiting for visitors. Perhaps one day, human footprints will join the tracks already left behind by robotic explorers. Perhaps astronauts will stand beside Olympus Mons, gaze into the depths of Valles Marineris, and watch the soft blue glow of a Martian sunset with their own eyes. And as they look across those endless crimson landscapes, they may wonder the very same question that has inspired generations of dreamers before them. Could these mountains, these valleys, these ancient rocks, be quietly protecting the smallest clues that life once found a way to begin here? The answer has not yet been found. But every new mission brings humanity one careful step closer to discovering whether Mars is simply a beautiful desert, or the silent keeper of one of the greatest stories the universe has ever written. The longer we remain on Mars, the more the planet begins to reveal its quiet personality. Nothing here happens in a hurry. The wind moves gently across the open plains, lifting tiny grains of reddish dust into the thin atmosphere. Those grains are so fine that they almost resemble powder. They cling to rocks, settle on cliffs, coat robotic explorers, and slowly reshape the landscape one gentle breeze at a time. Although Mars appears calm, it is home to some of the largest dust storms ever observed in the solar system. Most begin as small, local storms. A gust of wind lifts dust into the air. That dust absorbs sunlight, warming the atmosphere around it. The warmer air rises, creating stronger winds that lift even more dust. Little by little, the storm grows. Sometimes it remains confined to one region. But every few years, something remarkable happens. The storm expands until it blankets nearly the entire planet. Imagine standing on Mars as the horizon slowly disappears behind a wall of rust-colored dust. The sun grows dimmer. The sky becomes darker. Day begins to resemble evening. For weeks, or even months, fine particles swirl through the atmosphere, hiding mountains, valleys, and craters beneath a veil of crimson haze. From orbit, Mars transforms into a smooth orange sphere, with almost no surface features visible beneath the dust. Yet even these enormous storms are strangely gentle. Because the atmosphere is so thin, the winds do not push with the same force they would on Earth. They move quickly, but there is so little air that a person wearing a proper spacesuit would not be blown away. Instead, the greatest challenge would be the dust itself. Martian dust is incredibly fine. It slips into tiny spaces, sticks to equipment through static electricity, and slowly covers everything it touches. For robotic explorers, dust has been both friend and enemy. Some solar-powered rovers have nearly lost all their energy as dust settled across their solar panels, blocking precious sunlight. Then, almost like a gift from the planet itself, a passing dust devil would sweep across the landscape and clean the panels, allowing the rover to continue its mission. Scientists jokingly called these unexpected events cleaning miracles. It was as though Mars had decided to help its tiny robotic visitors survive a little longer. One of the most famous explorers to experience this kindness was Opportunity. Originally designed to operate for only about 90 Martian days, it continued exploring for nearly 15 years. It traveled farther than any previous rover, discovering evidence that ancient Mars once contained water. Eventually, however, a global dust storm covered the skies. Sunlight became too weak to recharge its batteries. Slowly, Opportunity fell silent. Its final message has often been remembered as a symbol of perseverance. Even today, many people feel an emotional connection to that little machine, patiently exploring an empty world until it could continue no longer. Yet Mars did not remain silent for long. New explorers soon arrived. Each carried more advanced instruments than the last. Each searched for another piece of the ancient puzzle. Curiosity rolled across Gale Crater, climbing rocky hills and studying layers of stone that recorded billions of years of planetary history. Later came Perseverance. Its destination was Jezero Crater, a place scientists believe once contained a river delta. On Earth, river deltas are remarkable places. As rivers slow before entering lakes or oceans, they deposit layers of mud, sand, and tiny particles. Those sediments can preserve signs of ancient life for millions of years. If Mars ever hosted microscopic organisms, a river delta would be one of the best places to search for their remains. Perseverance has been carefully drilling into selected rocks, collecting small cylindrical samples. Each sample is sealed inside a special tube and left on the surface for a future mission to retrieve. The hope is that one day these samples will travel all the way back to Earth. There, scientists using powerful laboratories could examine them in extraordinary detail. Perhaps hidden within those ancient rocks lies evidence of organic molecules. Perhaps traces of environments once suitable for life. Or perhaps even the faintest chemical fingerprints left behind by microscopic organisms billions of years ago. No one knows. That uncertainty is exactly what makes exploration so exciting. Every carefully collected sample carries with it the possibility of rewriting humanity's understanding of life in the universe. Not because scientists expect dramatic discoveries around every corner, but because nature often reveals its greatest secrets quietly. One rock, one mineral, one tiny fossil, one unexpected chemical signature. History has shown that the smallest discoveries sometimes change everything. As Perseverance continues its patient work, another remarkable companion occasionally lifts into the Martian sky. This tiny aircraft is called Ingenuity. Before its arrival, no powered aircraft had ever flown on another planet. Many engineers wondered whether flight was even possible in such a thin atmosphere. The air on Mars is less than 1% as dense as Earth's. Flying there is much more difficult than flying here. Ingenuity solved this challenge by spinning its lightweight blades at astonishing speeds. With each successful flight, it proved that powered flight on another world was possible. Its short journeys helped scouts on Earth imagine a future where larger helicopters might one day explore cliffs, caves, and hidden valleys that wheeled rovers cannot easily reach. Even though Ingenuity eventually completed its mission, it opened the door to an entirely new way of exploring other planets. Every mission to Mars builds upon the achievements of those that came before. Each rover follows the tracks of another dream. Each discovery inspires another question. And through it all, one quiet mystery continues to wait beneath the dust. If Mars once had rivers, if it once had lakes, if it once possessed a thicker atmosphere and a warmer climate, could life have taken its very first tiny breath on this distant world, long before humans ever looked up and wondered what secrets the red planet might be keeping? For now, Mars remains wonderfully silent. But silence does not always mean emptiness. Sometimes, it simply means the story has not yet been fully told. As night slowly settles across Mars, the planet becomes even more peaceful. The already quiet landscape falls into an almost unimaginable silence. There are no cities glowing in the distance. No airplanes leaving bright trails across the sky. No distant traffic. No sounds of birds greeting the evening. Only an endless wilderness stretching beneath millions upon millions of stars. If you stood on the surface wearing a spacesuit and looked upward, the sky would feel strangely familiar and completely different at the same time. Many of the same constellations visible from Earth could still be seen, although they would appear from a slightly different angle. The stars would shine with remarkable clarity through the thin atmosphere, almost as if the universe itself had moved a little closer. One familiar object would immediately catch your attention. Earth. Our home would no longer fill your entire world. Instead, it would appear as a brilliant blue-white point of light shining quietly among countless other stars. From Mars, our planet would look no larger than a bright evening star appears from Earth. Every ocean, every mountain, every forest, every city, every human being who has ever lived, would exist on that tiny point of light. It is a humbling thought. Sometimes, changing where we stand changes how we see everything else. Looking back toward Earth from Mars reminds us how precious and fragile our home truly is. The distance between the two planets changes constantly as they travel around the Sun. At their closest, they are separated by tens of millions of kilometers. At their farthest, more than 400 million kilometers lie between them. Because of these enormous distances, even light takes time to travel. A radio message sent from Earth does not arrive instantly. Depending on where the planets are in their orbits, communication may take anywhere from a few minutes to more than 20 minutes in one direction. Imagine speaking to someone, then patiently waiting many long minutes before hearing a reply. Future astronauts on Mars will experience this every single day. Real-time conversations with Earth will not be possible. Instead, every message will become something thoughtful and deliberate. Questions will require patience. Answers will arrive slowly. Perhaps that slower rhythm will encourage people to appreciate communication in a different way. Mars teaches patience. Nothing there happens quickly. The planet itself seems to invite careful observation rather than hurried conclusions. As the hours pass, temperatures begin falling rapidly. Without a thick atmosphere to trap heat, warmth escapes easily into space. Even after a relatively mild afternoon, nighttime temperatures can plunge far below freezing. the ground cools. The rocks release their stored heat. The thin air grows colder with every passing hour. Yet despite these harsh conditions, frost sometimes appears before sunrise. Tiny crystals of ice form quietly upon the surface, sparkling briefly in the first light of morning before disappearing once again. Even on one of the coldest worlds visited by humanity, beauty still finds a way to appear. The changing seasons bring more surprises. Mars experiences spring, summer, autumn, and winter much like Earth does. This happens because the planet is tilted on its axis by about 25 degrees, remarkably similar to Earth's tilt. As Mars journeys around the Sun, sunlight reaches different regions at different times of the year. Polar ice expands during winter. It retreats again during summer. Clouds drift across the atmosphere. Dust storms become more common during certain seasons. The rhythm feels strangely familiar. Yet one important difference remains. A year on Mars lasts much longer than a year on Earth. While our planet completes one orbit around the Sun in about 365 days, Mars takes approximately 687 Earth days. A Martian year is nearly twice as long. If you celebrated your birthday while living on Mars, you would wait almost 2 Earth years before celebrating the next one. Days, however, are surprisingly similar. A single Martian day, known as a sol, lasts just a little longer than an Earth day. Only about 39 extra minutes separate them. That small difference has proven surprisingly convenient for scientists controlling robotic missions. Engineers often adjust their schedules to match the Martian day, waking and sleeping according to the rhythm of another world. For weeks at a time, their lives become synchronized with the sunrise and sunset on Mars instead of those on Earth. It is a small reminder that exploration changes not only our understanding of distant planets, but also the lives of the people studying them. Perhaps one day, human settlers will experience these longer years and slightly longer days as part of everyday life. Children may grow up measuring time differently. Calendars may include Martian seasons. Families might celebrate holidays beneath a pale salmon-colored sky. The idea sounds like science fiction today. Yet history has often shown that tomorrow's ordinary life begins as yesterday's impossible dream. Still, one challenge continues to stand in the way: radiation. Without a strong global magnetic field and without a thick atmosphere, the surface of Mars receives much more harmful radiation than Earth. Invisible particles from deep space and energetic bursts from the Sun constantly reach the ground. For humans planning to live there, protection from radiation will be essential. Future homes may be built beneath the surface. Some could be covered with thick layers of Martian soil. Others might be constructed inside ancient lava tubes, natural underground tunnels formed billions of years ago when flowing lava cooled on the outside while remaining molten within. These enormous caves could provide shelter from radiation, extreme temperatures, and tiny meteorites. It is fascinating to imagine that the safest place for future explorers might not be on the surface at all, but hidden beneath the planet they have traveled so far to reach. Mars always seems to offer another mystery. Another possibility. Another reason to keep exploring. And somewhere beneath those quiet plains, frozen ice, ancient volcanoes, and underground caverns, the greatest question still waits patiently. Could life have adapted to survive where sunlight never reaches? Could tiny organisms still exist deep below the surface, protected from radiation and nourished by hidden pockets of water? No telescope can answer that. No satellite can see deeply enough. Only future explorers, and perhaps future generations of scientists, may one day uncover the truth hidden beneath the silent red dust. As dawn slowly returns to Mars, the first rays of sunlight spread gently across the endless plains. The light arrives quietly. There is no chorus of birds announcing the morning. No rustling forests awakening with the breeze. Only a soft glow stretching across rocks that have remained almost unchanged for billions of years. The sun rises over the horizon, appearing noticeably smaller than it does from Earth. Because Mars is farther from the sun, only about half as much sunlight reaches its surface. Even during the brightest part of the day, the landscape has a gentle, muted appearance, as though the planet is wrapped in an endless early morning. It is peaceful, almost dreamlike. As the sunlight reaches the dusty ground, the temperature slowly begins to climb. Yet Mars never becomes truly warm across most of its surface. Near the equator, a pleasant afternoon may briefly feel comfortable in direct sunlight. But the moment the sun begins to sink, the warmth disappears almost as quickly as it arrived. The planet cannot hold on to its heat for very long. Its thin atmosphere allows warmth to escape into the vast emptiness of space. This constant cycle of warming and cooling has shaped Mars for countless ages. Rocks expand slightly during the day. They contract again during the cold nights. Over millions of years, even solid stone begins to crack. Tiny fragments break away. The wind carries them across the surface. Slowly, patiently, Mars continues sculpting itself, one grain of dust at a time. Among these quiet landscapes, scientists have discovered something both simple and extraordinary: organic molecules. The word organic often causes excitement because every known form of life on Earth is built from organic chemistry. However, organic molecules alone do not prove that life exists or once existed. They can also form through completely natural geological processes without the involvement of living organisms. Even so, their discovery is important. It tells us that some of the basic chemical ingredients associated with life are present on Mars. Imagine opening an ancient book. You find letters arranged across its pages. Those letters alone do not tell you whether the book contains a story, a poem, or simply random symbols. But they show that the building blocks of language are there. Scientists view organic molecules in much the same way. They are pieces of a much larger puzzle. Another fascinating discovery came from the Martian atmosphere itself. Sensitive instruments have occasionally detected tiny amounts of methane gas. On Earth, much of our methane is produced by living organisms, although volcanoes and certain geological reactions can create it as well. The mystery lies in its changing concentration. Sometimes methane appears. Later it almost vanishes. Scientists continue debating why this happens. Could underground chemical reactions release small bursts of gas? Could hidden reservoirs occasionally leak into the atmosphere? Or could microscopic organisms living far beneath the surface somehow be responsible? At the moment, no one knows. The mystery remains wonderfully unsolved. And perhaps that is exactly why Mars continues capturing our imagination. Each answer opens another question. Each discovery reveals another layer of mystery. The planet never seems eager to give away all of its secrets at once. Meanwhile, far above the surface, satellites continue circling the red planet. They quietly photograph valleys, volcanoes, polar ice caps, and ancient river channels. Every orbit adds another piece to an increasingly detailed map. Together, these spacecraft have transformed Mars into one of the best-studied planets beyond Earth. Scientists can examine individual rocks from orbit. They can monitor dust storms as they spread across continents. They can even observe changes in the polar ice as the seasons come and go. Yet despite all this remarkable technology, enormous regions remain unexplored. Many places have never been visited by a rover. Others have never been photographed in great detail. Hidden beneath cliffs and inside deep caves may lie discoveries waiting for future generations. Some researchers are especially interested in those underground caves. Long ago, rivers of molten lava flowed across parts of Mars. As the outer layer cooled and hardened, molten rock continued flowing beneath it. Eventually the lava drained away, leaving behind long hollow tunnels. These lava tubes may be enormous. Some could easily contain entire buildings. Inside them, temperatures remain more stable. Radiation levels are lower. Dust storms cannot reach as deeply. If humans one day build permanent homes on Mars, these natural shelters may become some of the safest places to live. It is remarkable to think that a planet once shaped by violent volcanic eruptions may eventually protect human explorers within those very same ancient tunnels. The universe often works in unexpected ways. What once seemed destructive can later become protective. What appears empty may quietly hold the greatest possibilities. As scientists continue studying Mars, another realization becomes increasingly clear. Finding life does not necessarily mean discovering forests, animals, or advanced civilizations. The first evidence could be incredibly small. Perhaps a fossil no larger than a grain of sand. Perhaps unusual chemical patterns trapped inside ancient rock. Perhaps microscopic cells frozen beneath layers of ice. Such a discovery might seem tiny to the eye. Yet its meaning would be enormous. It would tell us that life is not unique to Earth. That under the right conditions, nature may find a way to create living systems on more than one world. And if life emerged independently on Mars, then perhaps it has appeared elsewhere across our galaxy as well. Suddenly, the universe would feel much less lonely. For now, however, Mars keeps its greatest secret safely hidden. The winds continue drifting across silent deserts. The frozen poles quietly grow and shrink with the seasons. Ancient volcanoes stand motionless beneath pale skies. And somewhere below that endless blanket of rust-colored dust, the answer may already exist. Waiting patiently. Not hiding from humanity. Simply waiting for the moment when our curiosity, our technology, and our understanding are finally ready to uncover it. The more we learn about Mars, the more it begins to feel less like a distant object in the night sky and more like a place with its own long and remarkable history. Every planet has a story. Earth's story is written in oceans, forests, mountains, and living creatures. The Moon tells its story through silent craters left by ancient impacts. Mars tells its story differently. Its pages are made of stone. Its memories are preserved beneath layers of reddish dust. Unlike Earth, where rain, rivers, oceans, and moving continents constantly reshape the surface, Mars has changed much more slowly over the last several billion years. Because of this, scientists often describe Mars as a natural museum of the early solar system. Walking across its surface would be like stepping into a time capsule that has remained sealed since before complex life appeared on Earth. One of the greatest clues to that ancient history comes from the countless craters scattered across the planet. Some are small enough to fit inside a city. Others stretch hundreds of kilometers across. Each one marks the place where an asteroid or comet collided with Mars long ago. Many of these impacts happened during a period known as the Late Heavy Bombardment, when the young solar system was filled with countless rocks left over from the formation of the planets. For millions of years, worlds throughout the solar system experienced frequent collisions. Earth was struck. The Moon was struck. Mars was struck. The difference is that Earth's active geology has erased much of that violent past. Mars has preserved it. Looking at its cratered surface is like reading an ancient diary written billions of years ago. Some impact craters reveal another fascinating secret. Around their edges, scientists have discovered minerals that could only have formed in the presence of water. This suggests that when enormous asteroids struck the frozen ground, the tremendous heat briefly melted underground ice. For a short time, warm pools of water may have existed inside those craters. These temporary lakes could have remained liquid for thousands or even tens of thousands of years before freezing once again. On Earth, wherever water and energy come together, life often follows. Could the same have happened on ancient Mars? Perhaps tiny microorganisms found shelter inside those warm crater lakes. Perhaps they survived for generations before the water slowly disappeared. Or perhaps life never gained a foothold at all. Mars keeps that answer locked within its oldest rocks. Another intriguing possibility lies beneath the surface. Even today, many scientists believe that underground Mars may still be very different from the dry world we see above. Deep below the frozen crust, temperatures slowly increase. If enough heat remains inside the planet, pockets of liquid water could still exist far beneath the surface. These hidden reservoirs would never see sunlight. As we continue our peaceful journey, let us imagine something that has never happened before. A human being steps onto the surface of Mars. The spacecraft has landed safely. Its engines have fallen silent. Outside the window stretches an endless landscape of red dust, scattered rocks, distant hills, and a sky unlike any ever seen from Earth. Inside the habitat, there is a moment of complete stillness. The astronaut takes one slow breath. Every movement is careful. Every checklist is followed with quiet precision. Finally, the airlock opens. A boot gently touches the Martian ground. For the first time in history, humanity has arrived on another planet. The footprints left behind may remain there for millions of years. On Earth, wind, rain, rivers, and growing plants gradually erase our tracks. Mars is different. Its thin atmosphere and dry climate allow marks in the soil to survive for incredibly long periods. Those first footprints could outlast entire civilizations on Earth. Future explorers might discover them thousands of years from now, still resting exactly where they were first made. The thought is both simple and extraordinary. One small step. One permanent mark. One unforgettable moment in the history of exploration. But living on Mars would be far more difficult than simply landing there. Every breath would depend upon technology. Every drop of water would be precious. Every meal would require careful planning. Unlike Earth, Mars offers no forests filled with oxygen. No flowing rivers ready to drink from. No comfortable atmosphere waiting outside the door. Everything needed for survival would have to be created. Future habitats may resemble small scientific villages. Rounded buildings connected by enclosed passageways. Solar panels quietly collecting sunlight. Machines steadily recycling water and air. Greenhouses glowing softly with rows of vegetables growing under artificial lights. Plants would become more than food. They would help produce oxygen. They would recycle carbon dioxide. They might even provide a comforting reminder of home. Imagine walking through a greenhouse after spending hours surrounded by endless red deserts. The sight of green leaves could become one of the most beautiful experiences imaginable. Scientists are already studying which crops might grow best in Martian conditions. Potatoes, lettuce, tomatoes, beans, wheat. Each experiment teaches us a little more about the possibility of one day building permanent communities beyond Earth. Water will remain one of the greatest treasures. Rather than searching for lakes on the surface, future explorers will likely dig into the frozen ground. Beneath the dust lie vast deposits of water ice. Special equipment could heat that ice until it melts. The water could then be purified for drinking, cooking, washing, and growing food. Nothing would be wasted. Every drop would be carefully recycled again and again. Life on Mars would teach humanity the true value of resources we often take for granted. Even the air inside a habitat would constantly circulate through advanced recycling systems. Carbon dioxide exhaled by astronauts could be converted back into oxygen. Water released through breathing and perspiration could be collected, cleaned, and reused. On Mars, recycling would not simply be environmentally friendly. It would be essential for survival. Outside the habitat, explorers would travel carefully across the landscape in specially designed vehicles. Each journey would require detailed planning. Unexpected dust storms, extreme cold, equipment failures, radiation exposure. Every expedition would demand patience and preparation. Yet the rewards could be extraordinary. Perhaps a rover detects unusual minerals inside an ancient cliff. Astronauts carefully collect rock samples. Months later, laboratories discover evidence that those rocks formed beneath warm underground springs billions of years ago. Or perhaps they uncover a fossilized microbial structure unlike anything previously seen. A discovery so small it fits inside the palm of a hand. Yet so important it changes humanity's understanding of the universe forever. This is why Mars continues calling to scientists. Not because we expect dramatic surprises every day, but because history has shown that patient exploration often reveals extraordinary truths. Sometimes the greatest discoveries arrive quietly. One careful observation, one unexpected measurement, one tiny fragment of ancient stone. As evening returns to Mars, the explorers slowly make their way back toward their habitat. Behind them, fresh footprints stretch across the dusty ground. Ahead, warm lights glow softly through reinforced windows. Inside waits safety. Outside stretches an entire planet still waiting to be understood. The stars begin appearing one by one above the silent landscape. Among them shines a small blue point. Earth. From this distant world, it looks peaceful, fragile, beautiful. The place where every story of humanity began. Perhaps one day, people living on Mars will look toward the tiny blue light with the same sense of wonder that people on Earth have always felt while looking toward the red planet. Two neighboring worlds, separated by millions of kilometers, connected by curiosity, connected by exploration, and connected by one timeless question that still echoes across the quiet valleys and ancient mountains of Mars. If life found a way to begin on Earth, could it have found a way to begin here as well? The answer remains hidden beneath layers of dust older than the oldest civilizations, waiting with remarkable patience for the day humanity is finally ready to listen to what the red planet has been quietly trying to tell us all along. As the night grows deeper, let your imagination drift far beneath the dusty surface of Mars. The world above is cold, dry, and silent. But below the ground, another story may still be waiting. Scientists believe that just a few meters beneath the surface, temperatures become more stable. Travel even deeper, and the environment changes again. The freezing cold of the surface slowly gives way to warmer layers hidden inside the planet. No human has ever looked into these deep underground regions. Everything we know comes from careful observations, computer models, and comparisons with Earth. Yet those clues paint a fascinating picture. Imagine descending into a natural cave formed billions of years ago by flowing lava. The entrance is small, almost hidden beneath a rocky hillside. As you move farther inside, the sunlight disappears completely. The air remains cold, but the temperature hardly changes. Outside, fierce dust storms race across the plains. Inside, everything is calm. These lava tubes are among the most exciting places scientists hope to explore one day. Some may stretch for many kilometers beneath the surface. Others could be large enough to hold entire neighborhoods. Because they are protected by thick layers of rock, they naturally block much of the harmful radiation that reaches the surface. For future astronauts, such caves might become the safest homes on Mars. Instead of building every shelter from scratch, explorers could use nature itself as protection. The walls that once carried rivers of molten lava may one day protect human families. It is a remarkable thought. A place born from fire becoming a refuge for life. Scientists are especially interested in these underground spaces for another reason. If life still exists on Mars today, caves may be among the best places to search. The surface is exposed to intense radiation. Temperatures change dramatically between day and night. Liquid water is extremely unstable. But underground, conditions could be much gentler. There may be hidden ice. There may even be salty pockets of liquid water trapped beneath layers of rock. On Earth, life has an extraordinary ability to survive in hidden places. Deep inside caves, microorganisms live without sunlight. Some feed on minerals dissolved in water. The tiny red point of light became a real place. The imagined world became a landscape filled with mountains, valleys, storms, and ancient secrets. The first attempts to study Mars began with telescopes. Early astronomers carefully watched the planet as it moved across the sky. They noticed changing patterns on its surface and wondered what they meant. Some believed they were seeing oceans. Others imagined continents. Some even thought they saw artificial structures created by intelligent beings. These ideas were understandable. When humans look into the unknown, imagination often fills the spaces where knowledge is missing. Mars became a canvas for dreams. Stories were written about civilizations living beneath its surface. Books described mysterious creatures traveling from the red planet to Earth. Movies and novels transformed Mars into a symbol of both wonder and fear. But slowly, science replaced imagination with evidence. Spacecraft began traveling across the enormous distance between Earth and Mars. For the first time, humanity could see the planet up close. The blurry red circle in the sky became a real world with real landscapes. The first images revealed a surprising truth. Mars was not a planet covered in giant cities or mysterious canals. Instead, it was a quiet desert world filled with ancient scars from a distant past. Early spacecraft flew past Mars and captured the first close photographs. Each image answered some questions while creating many more. The planet had craters, mountains, valleys, dust, a thin atmosphere. But where was the water? Where were the signs of life? The mystery continued. Later missions entered orbit around Mars and began studying the planet in much greater detail. They mapped the surface, analyzed minerals, measured the atmosphere, observed seasonal changes. Slowly, Mars transformed from an unknown world into one of the most scientifically understood planets beyond Earth. Yet even today, many mysteries remain. One of the most important explorers was a small robotic vehicle named Sojourner. It arrived on Mars in the late 1990s as part of the Pathfinder mission. Although tiny compared with modern rovers, Sojourner represented a huge achievement. It proved that a mobile robot could travel across another planet. It photographed the landscape, examined rocks, and showed that exploring Mars was possible. Then came larger and more advanced explorers. Spirit and Opportunity arrived in 2004. Their mission was designed to last only a few months. But Opportunity continued working for almost 15 years. It traveled across ancient plains, climbed hills, and discovered powerful evidence that water once existed on Mars. The little rover became a symbol of determination. Millions of people followed its journey. They watched as it survived dust storms, difficult terrain, and the harsh conditions of another world. Its story reminded humanity of something important. Exploration is not only about machines and technology. It is about curiosity. It is about the desire to understand something greater than ourselves. Later, Curiosity arrived with even more advanced instruments. Unlike earlier rovers, Curiosity was not powered mainly by sunlight. Instead, it carried a nuclear power system that allowed it to continue operating through seasons and dust storms. Its mission focused on a place called Gale Crater. Scientists believe this enormous crater once contained a lake. Inside its ancient rocks, Curiosity discovered evidence of environments that may have been suitable for microbial life. Not proof that life existed, but proof that Mars once had conditions where life could potentially survive. Then came Perseverance, a rover built specifically to search for signs of ancient life. It landed in Jezero Crater, a region chosen because scientists believe a river once flowed into an ancient lake there. A river delta, a place where sediments gathered. A place where traces of ancient organisms, if they ever existed, might have been preserved. Perseverance carries instruments capable of studying rocks in incredible detail. It can analyze chemical compositions, examine minerals, search for signs of ancient environments. It also carries something even more important: samples. Small pieces of Mars carefully selected and stored for a future journey back to Earth. Those samples could become some of the most valuable scientific objects ever collected. A single rock from Mars could reveal information about another planet's climate, chemistry, and perhaps even the history of life itself. Scientists may one day place these samples under powerful microscopes and discover something that changes our understanding of existence. Or they may discover something equally fascinating: that Mars never developed life at all. Both possibilities are extraordinary, because each answer teaches us something fundamental. If Mars had life, then life may be common throughout the universe. If Mars never had life despite having water and suitable conditions, then perhaps the creation of life requires something rare and special. Either discovery would reshape science. Either discovery would change how humanity sees its place among the stars. And so the journey continues. Robots quietly explore. Scientists patiently analyze. Engineers design new spacecraft. Dreamers imagine future missions. All of them are searching for one thing. Not simply a planet. Not simply a destination. But an answer to one of the oldest questions humans have ever asked. Are we alone? Somewhere beneath the ancient skies of Mars, beneath layers of dust and stone, the answer may already exist. The universe is waiting. And humanity is still listening. As we continue drifting across the silent landscapes of Mars, another mystery begins to appear. It is not found on the surface. It is not hidden inside a mountain. It is written in the very air surrounding the planet. The atmosphere of Mars. A thin, delicate layer of gas that tells the story of a world that has changed dramatically over billions of years. Today, the Martian atmosphere is incredibly different from Earth's. Standing on the surface without protection would be impossible for humans. The air pressure is less than 1% of what we experience at sea level on Earth. The atmosphere is so thin that a person would not feel a gentle breeze in the same way they do at home. The sky would not have the same deep blue appearance. The clouds would not be thick and white. Everything would feel distant, quiet, and unfamiliar. But billions of years ago, Mars may have possessed a much thicker atmosphere. A warmer blanket of gases surrounded the planet. That atmosphere helped regulate temperatures. It allowed water to remain stable on the surface for longer periods. It created conditions where rivers could flow and lakes could exist. Somewhere along the journey of time, Mars lost much of that protective layer. Scientists believe the disappearance of the planet's magnetic field played a major role. Deep inside Earth, our planet's liquid metal core creates a powerful magnetic shield. This invisible protection stretches far into space, helping defend our atmosphere from particles carried by the solar wind. Mars once may have had a similar shield. But as the planet cooled, its internal activity slowed. The magnetic field weakened. Eventually, much of that protection disappeared. Without this shield, tiny particles from the sun began interacting directly with the upper atmosphere. Slowly, over millions and billions of years, gases escaped into space. The process was incredibly slow. Not a sudden event. Not a dramatic explosion. Just a quiet transformation happening over unimaginable lengths of time. A few molecules escaping today. A few more tomorrow. A few more after thousands of years. Eventually, the difference became enormous. A planet that may once have held rivers and lakes became the dry world we see now. This teaches us something important about planets. Worlds are not permanent. They change. They evolve. They can lose the very conditions that once made them comfortable. Earth and Mars began their journeys in a similar neighborhood around the same star. Both formed from the same ancient cloud of dust and gas. Both experienced impacts. Both contained water. Both developed atmospheres. Yet their paths became completely different. Earth remained protected by its magnetic field, active geology, and abundant surface water. Mars followed another road. A colder road. A quieter road. A road toward a frozen desert. But even in its current state, Mars is not completely lifeless in terms of activity. The planet still experiences changes. Seasons arrive and disappear. Ice moves between the poles and atmosphere. Dust storms reshape the surface. The ground expands and contracts with temperature changes. Occasional Marsquakes remind us that the planet is not entirely asleep. NASA's InSight mission provided scientists with valuable information about the interior of Mars. For the first time, instruments carefully listened to the planet's internal movements. Small vibrations traveled through Martian rock. Each signal revealed something about what lies beneath the surface. Just as doctors use sounds from the human body to understand health, Scientists use planetary vibrations to study worlds. A planet has its own heartbeat. Mars has a quiet one. Every tremor carries information from deep underground. It reveals the structure of the crust. It helps scientists understand the planet's history. It shows that beneath the calm surface, Mars still has an active story unfolding. Another fascinating part of Mars is its polar regions. At the top and bottom of the planet, enormous ice caps grow and shrink with the changing seasons. They are not identical to Earth's ice caps. Mars has a large amount of frozen carbon dioxide mixed with water ice. During the cold winter months, carbon dioxide from the atmosphere freezes directly onto the surface. When warmer seasons arrive, that frozen carbon dioxide returns to the atmosphere. The planet itself breathes in a slow seasonal rhythm. The changes are subtle, almost invisible. But over time, they reshape the entire atmosphere. Scientists carefully monitor these cycles because they reveal how Mars behaves today. The polar regions also preserve clues about the past. Layers of ice contain information from different periods of Martian history. Like tree rings on Earth, these layers may record ancient changes in climate. Each layer is a frozen memory, a snapshot of conditions that existed thousands or millions of years ago. If future explorers could safely study these ice deposits, they might uncover valuable information about when Mars was warmer, wetter, and possibly more suitable for life. Perhaps they could even discover trapped molecules from ancient environments. A chemical message preserved in ice. A tiny record of a forgotten era. As we look across the frozen landscape, it becomes clear that Mars is not simply a dead planet. It is a world that has transformed. A world that lost oceans but kept memories. A world that lost a thick atmosphere but preserved evidence of its ancient past. And somewhere within those memories lies the answer to the question that brought us here. Was Mars once alive? Or did it simply come close to becoming a second Earth, only to follow a different path? The search continues beneath the red dust, beneath the ancient ice, and perhaps even beneath the surface where sunlight has never reached. Because Mars may not be hiding a story about another world. It may be hiding a story about life itself. A story that could explain not only where we came from, but how many other worlds across the universe may be waiting for their own chance to awaken. As the quiet journey across Mars continues, we begin to look beyond the surface and into one of the most fascinating possibilities of all. The possibility that life, if it ever existed on Mars, may not have disappeared completely. Perhaps it changed. Perhaps it moved. Perhaps it found shelter in places where the harsh surface could never reach. When people imagine life on another planet, they often picture something large and obvious. Strange creatures walking across alien landscapes. Plants growing beneath unfamiliar skies. But science tells us that the first life beyond Earth may look nothing like those stories. It may be incredibly small. So small that it would require powerful microscopes to see. On Earth, the earliest forms of life were microscopic. Tiny organisms appeared long before forests, animals, or humans existed. They survived through changing environments, adapting to extreme conditions over billions of years. This gives scientists an important clue. If life ever began on Mars, the earliest evidence would most likely be microscopic as well. Perhaps ancient microbes lived in warm pools of water. Perhaps they existed near underground springs. Perhaps they survived near volcanic regions where minerals provided energy. The possibilities are many. The evidence, however, remains hidden. One of the most exciting places to search is ancient lake environments. Mars once contained many places where water gathered. Some lakes may have existed for thousands or millions of years. During that time, sediments slowly settled to the bottom. Tiny particles from the surrounding landscape collected layer after layer. On Earth, these sediments often preserve signs of ancient life. Fossils, chemical traces, patterns created by biological activity. Scientists hope that Martian sediments may have preserved similar clues. Imagine holding a small piece of rock from Mars. To the human eye, it might look ordinary. A simple stone. A piece of ancient dust. But inside its microscopic structure could be a message from billions of years ago. A record from a time when another world may have had flowing water beneath a warmer sky. This is what makes Mars exploration so special. The greatest discoveries may not be obvious. They may not be dramatic. They may be hidden in details too small to notice without patience and advanced technology. The search for life requires humility. Scientists must carefully separate what they hope to find from what the evidence actually shows. A strange chemical pattern does not automatically mean life. A molecule associated with biology does not always come from biology. Nature can create surprising results through completely non-living processes. That is why every possible discovery is examined carefully. The goal is not to prove a dream. The goal is to discover the truth, even if the truth is different from what we expect. Another fascinating mystery involves Mars' ancient climate. How did a planet farther from the Sun maintain liquid water? Today, Mars is too cold and its atmosphere is too thin to support large bodies of liquid water on the surface. But ancient river valleys tell us something different. At some point in the past, conditions allowed water to flow. Scientists are still trying to understand exactly how. Perhaps Mars once had a thicker atmosphere filled with greenhouse gases. Perhaps volcanic activity released gases that warmed the planet. Perhaps temporary periods of warmth occurred after major volcanic events or asteroid impacts. The climate of ancient Mars remains one of planetary science's greatest puzzles. Solving this mystery could help us understand not only Mars but planets throughout the universe. Thousands of distant planets orbit other stars. Many may have conditions very different from Earth. By studying how Mars changed, scientists learn how worlds evolve. They learn how atmospheres disappear, how climates transform, how planets that begin with similar ingredients can follow completely different paths. Mars is like a natural experiment performed by the universe itself. 2 planets, 1 star, different outcomes. Earth remained a living world. Mars became a frozen desert. Understanding why could reveal something profound about the future of our own planet as well. As we continue exploring, another question appears. Could humans ever change Mars? Could we transform the planet into a place more similar to Earth? This idea is known as terraforming. For decades, writers and scientists have imagined a future where humans increase Mars' temperature, thicken its atmosphere, and create conditions where liquid water can remain stable. It is a fascinating idea. A planet slowly awakening. Frozen landscapes becoming warmer. The sky becoming thicker. New environments appearing. But the reality would be extraordinarily difficult. Mars does not have enough easily available atmosphere to simply release. Its weak gravity makes holding a thick atmosphere challenging. The planet lacks the strong magnetic protection that helps shield Earth. Even with advanced technology, transforming Mars would require enormous amounts of energy and resources. It would not happen quickly. Perhaps not even within many human lifetimes. For now, the more realistic goal is not changing Mars into another Earth. It is learning how to carefully explore and live there while respecting the planet's natural environment. Mars does not need to become Earth to be valuable. Its uniqueness is exactly what makes it important. A world with its own history, its own mysteries, its own beauty. As the sun slowly disappears beyond the horizon, the red landscape becomes darker. The first stars appear. The cold evening air settles over ancient valleys and silent mountains. Somewhere below the surface, hidden from the fading light, the possibility of ancient life remains. Maybe Mars holds the remains of something that lived billions of years ago. Maybe it holds only the chemistry that could have created life but never did. Either answer would be extraordinary, because both possibilities teach us something about our place in the universe. Mars is not only a planet we are trying to understand. It is a question written across the cosmos. And humanity is still learning how to read the words hidden among the stars. The silence of Mars carries another fascinating mystery. A mystery written not only in rocks and ice, but in the very possibility of survival. If humans ever travel to Mars, they will not simply be visitors. They will become part of a completely new chapter in the story of exploration. For the first time, a species from Earth may attempt to live permanently on another planet. The idea feels almost impossible when we compare Mars to our comfortable home. Earth provides everything naturally. The atmosphere gives us oxygen. The oceans provide water. The soil supports plants. The magnetic field protects us from much of the radiation coming from space. Mars provides almost none of these things. Yet humans have always adapted. Our ancestors crossed frozen landscapes, deserts, oceans, and mountains. Every environment that once seemed impossible eventually became a place where people learned to survive. Mars would be the greatest challenge ever faced. The first explorers would likely live inside carefully designed habitats. These structures would not be ordinary buildings. They would be life support systems. Every wall, every machine, and every piece of equipment would have an important purpose. Inside, the atmosphere would need to be controlled constantly. Temperature would need to remain stable. Radiation protection would be essential. A small failure could become a serious emergency. Life on Mars would require teamwork unlike anything seen before. Scientists, engineers, doctors, and explorers would depend on each other every day. A single person could not survive alone. A Mars settlement would be a reminder that humanity's greatest achievements are usually created through cooperation. The journey itself would already be a remarkable challenge. Traveling to Mars would expose astronauts to months of isolation. During the trip, they would live inside a spacecraft moving through deep space. There would be no quick return home. No stepping outside for fresh air. No looking out a window and seeing a familiar landscape. Only the endless darkness of space surrounding them. Mental health would become just as important as physical health. Astronauts would need to handle loneliness, stress, and the psychological challenge of being millions of kilometers away from Earth. Future missions would require people who are not only physically prepared but emotionally resilient. The spacecraft would become a small world traveling between two planets. Inside that small world, every person would carry memories of Earth. The sound of rain. The smell of forests. The feeling of sunlight on a summer day. Simple experiences that might become incredibly valuable after months away. When explorers finally arrive at Mars, even ordinary things from Earth may feel extraordinary. A fresh vegetable. A message from family. A familiar song. A photograph of home. Small reminders that they are connected to the planet they left behind. But despite the difficulties, Mars offers something powerful. A chance to expand the human story. For thousands of years, humanity lived on one planet. Every civilization, every invention, every piece of art and knowledge, everything happened on Earth. Mars represents the possibility that the story could continue somewhere else. Not because Earth is no longer important, but because exploration has always been part of who we are. The same curiosity that led humans across oceans now pushes us across space. Yet before humans build cities on Mars, robotic explorers will continue preparing the way. Each rover is like a small pioneer. Each mission answers questions that future astronauts will need to know. Where is the safest landing location? Where can water be found? Which regions contain useful minerals? Where can habitats be protected from radiation? Every discovery brings the dream a little closer. One of the most important resources for future explorers may be something we rarely think about: the Martian soil. At first glance, the dusty ground appears lifeless. But beneath its surface are minerals that could become useful materials. Future technology may allow humans to extract resources from Martian soil and create tools, structures, and equipment. Instead of carrying every item from Earth, explorers may learn to build using materials already available on the planet. This idea could completely change how humans explore space. A mission to Mars is not simply about reaching a destination. It is about learning how to create a sustainable presence. A temporary visit is one thing. A permanent home is something completely different. The difference between the two is enormous. Visitors bring supplies. Settlers create systems. That transition will require innovation beyond anything we have attempted before. Perhaps future generations will look back at the first Mars missions the same way we look back at the earliest ocean voyages. The first ships crossing unknown seas seemed incredibly risky. But they changed human history. Mars may become the next great ocean. A vast unknown waiting to be explored. Not an ocean of water. An ocean of space. As another Martian night arrives, the planet once again becomes a quiet world beneath the stars. The same stars that guided ancient humans on Earth now shine above future explorers who dream of reaching another world. Mars remains distant. Mars remains difficult. Mars remains mysterious. But perhaps that is exactly why it calls to us. The most meaningful journeys are rarely the easiest ones. They are the journeys that challenge us to become something greater. And somewhere beneath the red dust, beneath the ancient valleys, beneath billions of years of silence, Mars continues waiting. Waiting for the moment when humanity finally steps forward and begins the next chapter of its cosmic story. As our peaceful journey through Mars continues, we begin to explore one of the most important questions surrounding the future of humanity. If life is possible on Mars, could Mars become a second home for humans? The idea has inspired scientists, writers, and dreamers for generations. A world beyond Earth. A place where future explorers might build habitats, conduct experiments, and perhaps even raise new generations beneath an alien sky. But before Mars can become a home, humanity must first understand the planet completely. Mars is not simply a place where we can arrive and begin living. It is a world that demands respect. Every decision must be carefully planned. Every resource must be used wisely. Every mistake could have serious consequences. The first human visitors would likely not live in large cities or futuristic buildings. Their homes would probably be small, carefully designed habitats built for survival. These habitats would need to protect people from the harsh environment outside. The thin atmosphere, the extreme temperatures, the constant radiation from space, the powerful dust storms. Every wall would become a shield. Every machine would become essential. Inside these habitats, life would feel very different from life on Earth. There would be no open windows where you could breathe fresh air. No walking outside without a spacesuit. No forests or oceans stretching beyond the horizon. The connection to Earth would remain strong because every person living on Mars would carry memories of the planet where humanity began. Yet over time, a new culture might develop. People born on Mars would experience the universe differently. For them, Earth would not be the only world they know. It would be the distant birthplace of their ancestors. A beautiful blue planet shining in the sky. A place they may visit someday, just as people today dream of visiting distant countries. The idea of humans living on another planet raises fascinating questions. Would Martian communities create their own traditions? Would they celebrate different holidays? Would they develop new ways of measuring time? Would they see themselves as Earth citizens living elsewhere, or as something completely new? These questions may sound like science fiction. But every major human change once began as an imagination. Thousands of years ago, people wondered what existed beyond the horizon. Then ships crossed oceans. Hundreds of years ago, people wondered if humans could fly. Then airplanes filled the skies. Today, humanity wonders if we can live beyond Earth. Perhaps Mars will become the next great chapter. However, survival on Mars depends on understanding one of its most valuable resources: water. Water is not only necessary for drinking. It is the foundation of almost every future activity. It can support agriculture. It can produce oxygen. It can be separated into hydrogen and oxygen to create rocket fuel. In many ways, finding water on Mars is like finding a hidden treasure. Fortunately, scientists have discovered evidence of enormous ice deposits beneath the surface. These frozen reserves may become essential for future missions. Machines could extract the ice, melt it, and transform it into useful resources. A future astronaut might walk across a dry Martian valley knowing that beneath their feet lies enough frozen water to support exploration for years. It is a strange contrast. A planet that appears completely dry may actually contain vast amounts of water hidden away. Mars teaches us that appearances can be misleading. A silent desert may hold forgotten oceans. An empty landscape may preserve ancient stories. A lifeless-looking world may still contain clues about life's possibilities. Another challenge for future settlers will be food. Growing plants on Mars will not be simple. The soil contains minerals but also substances that could be harmful. The atmosphere lacks the oxygen plants need in the same way they receive it on Earth. Temperature and sunlight are different. Future farmers on Mars will need controlled environments. Inside protected greenhouses, plants could grow using carefully prepared soil, artificial lighting, recycled water, and controlled air. These green spaces would become some of the most precious locations on the planet. Imagine entering a Martian greenhouse after walking across kilometers of empty desert. Inside, leaves move gently beneath artificial sunlight. Small drops of water collect on plant surfaces. The air feels alive. The color green becomes a reminder of home. Perhaps the first gardens on Mars will not simply provide food. They will provide hope. They will represent life continuing in a place where life once seemed impossible. Yet while humans dream of building on Mars, scientists also recognize the importance of protecting the planet. Mars may already have something valuable hidden within it. A possible ancient record of life. If humans explore carelessly, we could accidentally damage the very evidence we traveled millions of kilometers to discover. This is why planetary protection is so important. Before searching for life, we must ensure that we do not bring too much of our own life with us. Mars deserves careful exploration. Not because it is fragile like Earth, but because it may contain answers that belong to the entire universe. The discovery of life on Mars would not belong to one country or one generation. It would belong to everyone. It would change the way we see ourselves. Because suddenly, the story of life would become larger than Earth. We would know that nature created living systems on more than one world. The universe would feel less like an empty space. It would become a place filled with possibility. And perhaps somewhere, on another distant planet orbiting another star, another civilization may be looking upward and asking the same question. Are we alone? For now, Mars remains our closest opportunity to search for an answer. A quiet red world. A frozen desert. A planet full of mysteries. And perhaps, a world that has been waiting billions of years to reveal one of its greatest secrets. As the journey across Mars continues, we move toward one of the most fascinating mysteries of all. Not the mountains. Not the valleys. Not the ancient rivers. But the possibility that Mars may still be changing today. At first glance, Mars appears frozen in time. A quiet desert world where nothing moves. Deep below the surface, rocks crack and shift. Heat continues moving slowly through the interior. The planet still carries the memory of its fiery beginning. Billions of years ago, Mars was a much more active world. Volcanoes erupted. Lava flowed across enormous landscapes. The crust constantly changed. Today, those dramatic events have mostly stopped. But the planet still whispers through small movements beneath the ground. The study of these vibrations helps scientists understand the hidden structure of Mars. They can learn about the thickness of the crust, the composition of the interior, the size and condition of the core. It is similar to listening to the echoes inside a giant room. The way sounds travel reveals the shape of the space around them. Mars itself provides clues through its own natural signals. Another fascinating feature of Mars is its relationship with asteroids and space debris. Because Mars has a thin atmosphere, many small objects that enter its sky are not destroyed as easily as they would be on Earth. Some reach the surface. Others create brilliant flashes as they burn through the atmosphere. Over billions of years, countless impacts have shaped the planet. Every crater tells a story. Every scar represents a moment when something from space collided with Mars. These impacts may have influenced the possibility of life as well. Large asteroid strikes can be destructive. They can release enormous amounts of energy. But they can also create temporary environments where life might survive. Heat from an impact can melt underground ice. Minerals can become chemically active. New energy sources can appear. On Earth, some scientists believe early life may have benefited from similar energetic environments. Could impacts on ancient Mars have helped create opportunities for life? It is another possibility hidden inside the planet's long history. Mars is full of contradictions. It is cold, yet it may have once been warm. It is dry, yet it contains frozen water. It appears empty, yet it may preserve the remains of ancient life. It looks silent, yet it continues telling stories through science. Perhaps that is why Mars feels so familiar. It is not simply an alien world. It is a reminder of Earth's own journey. Our planet also changed dramatically over time. Earth was once a much different place. Continents moved. Atmosphere transformed. Life evolved. Extinctions occurred. The world we know today is only one moment in Earth's enormous history. Mars shows us that planets are not permanent. They are constantly becoming something new. This realization is important when scientists study distant planets beyond our solar system. Thousands of planets have been discovered orbiting other stars. Some may be larger than Earth. Some may be covered with oceans. Some may have thick atmospheres. Some may be completely different from anything we can imagine. Mars gives us a nearby example of planetary evolution. It helps us understand what happens when a world changes over billions of years. Perhaps studying Mars will help us recognize signs of life on planets far away. Perhaps it will teach us how common habitable environments are. Perhaps it will even help us understand Earth's future. The search for life beyond Earth is not only about finding another living world. It is also about understanding our own. Because when we explore Mars, we are asking deeper questions. What makes a planet suitable for life? How does life begin? How long can life survive? What conditions allow civilizations to exist? These questions connect Mars to something much larger than space exploration. They connect Mars to the story of existence itself. Imagine standing on a Martian hill at sunset. The landscape stretches endlessly in every direction. Ancient valleys disappear into the distance. The sky changes from pale gold to soft blue. The first stars appear above. For a moment, the silence feels overwhelming. Yet beneath that silence is a billion-year-old story. A story of oceans that vanished. A story of volcanoes that rose and fell. A story of a planet that transformed. And perhaps, a story of life waiting to be discovered. The search for answers continues. New spacecraft will arrive. New instruments will study the rocks. New generations of scientists will examine the clues left behind. Every mission brings humanity closer. Not just to Mars, but closer to understanding our place in the universe. Because somewhere within those ancient rocks and endless deserts lies a possibility that has fascinated humanity for generations. Maybe Mars was once alive. Maybe Mars still holds hidden life. Or maybe Mars teaches us something equally powerful. That even a world without life can still tell the most important stories. The story of planets. The story of change. The story of how the universe creates worlds. And how one small species on one small planet became curious enough to search for answers among the stars. As we continue our slow journey through the history of Mars, we begin to understand that the red planet is not only a place of scientific discovery. It is also a place of imagination. For generations, humans have looked toward Mars and wondered what the future might hold. Would we ever walk across its valleys? Would we ever build homes beneath its skies? Would we ever discover that we are not alone? These questions have followed humanity for a very long time. Mars became the first distant world where people seriously imagined another civilization. Long before spacecraft reached the planet, stories about Mars filled books, paintings, and conversations. People imagined advanced societies hidden beneath the surface. They imagined strange creatures looking back toward Earth. They imagined mysterious signals traveling through space. Although those stories were not based on scientific evidence, they reflected something important. A deep human desire to understand whether life exists beyond our own world. Today, science has replaced many old ideas with careful exploration. We know Mars does not appear to have large civilizations or visible signs of intelligent life. But the question of simple life remains. And in some ways, that question is even more fascinating. Because if tiny organisms evolved independently on Mars, it would mean that life itself may be much more common throughout the universe than we once believed. Imagine the moment when humanity receives undeniable evidence. Not a rumor. Not a guess. Not a possibility. Real evidence. A confirmed discovery that life existed on another planet. The discovery might come from a tiny fossil hidden inside a rock. A chemical pattern that could only be explained by biology. Or perhaps a living microorganism discovered beneath the surface. The scientific world would change forever. Every biology textbook would need new chapters. Every discussion about life's origins would become larger. The story of life would no longer begin only on Earth. It would become a universal story. A story written across multiple worlds. But even if Mars never developed life, that discovery would still be incredibly meaningful. It would show us that having water and suitable conditions does not automatically guarantee life. The universe may contain many worlds with oceans, atmospheres, and chemistry similar to Earth. Yet life may require something much rarer. Something we do not fully understand. This uncertainty is what makes the search so exciting. The universe does not reveal its secrets easily. It rewards patience. It rewards curiosity. It rewards those willing to ask difficult questions without knowing the answers. Mars has taught humanity this lesson many times. Every discovery creates a new mystery. When scientists found evidence of ancient water, they asked what happened to it. When they discovered organic molecules, they asked where they came from. When they detected possible methane changes, they searched for explanations. The journey never truly ends. Because science is not only about finding answers. It is about learning how to ask better questions. One of the most beautiful parts of Mars exploration is that it connects people across the entire planet. Scientists from different countries work together. Engineers combine knowledge from many fields. Researchers share discoveries with the world. A rover on Mars may be built by thousands of people who never meet each other. Some design cameras. Some create computer systems. Some study rocks. Some analyze signals arriving from millions of kilometers away. Together, they create something greater than any individual achievement. A bridge between two planets. This reminds us that exploration is not only about reaching new places. It is about what we learn along the way. The technology created for space missions often improves life on Earth. New materials. Advanced robotics. Better communication systems. Improved scientific instruments. The challenges of exploring Mars push humanity to create solutions that benefit our own planet. Mars also teaches us something about protecting Earth. When we look at the red planet, we see a world that lost much of its atmosphere and surface water. We see the consequences of planetary change. Earth and Mars began with many similarities. Both formed from the same early solar system. Both experienced impacts. Both contained water. Yet their futures became completely different. Studying Mars reminds us that planets are precious and unique. Earth is not simply a place where we happen to live. It is a rare environment that has allowed life to flourish for billions of years. The forests, the oceans, the atmosphere, the incredible diversity of living things. All of these are treasures. Looking at Mars from a distance gives us a new appreciation for home. A future astronaut standing on Mars might feel this more strongly than anyone. They would look back across the darkness of space and see Earth as a small blue world. No borders. No conflicts. No divisions visible from that distance. Only one planet. One home. One place where every human story began. Perhaps that is one of the greatest lessons Mars can teach us. Exploring other worlds helps us understand the importance of our own. The red planet is not only a destination. It is a mirror. A reflection that shows us where we came from and what we must protect. As another quiet evening settles across Mars, the planet returns to its familiar silence. Dust moves gently across ancient valleys. The polar ice continues its slow seasonal dance. The stars shine above a world that has waited billions of years. And somewhere between Earth and Mars, between curiosity and discovery, humanity continues searching. Searching for life. Searching for answers. Searching for our place in the endless universe. Because perhaps the greatest discovery waiting on Mars is not only what we find there, but what that discovery reveals about ourselves. As our journey through Mars continues, we now move deeper into one of the most mysterious parts of the planet's story. The hidden world beneath the surface. For centuries, humans looked at the sky and imagined distant lands above the clouds. But Mars teaches us that some of the greatest mysteries may not be above us. They may be below our feet. The surface of Mars tells only part of the story. The ancient valleys, mountains, and craters are like the cover of a book. The deeper pages remain hidden underground. Beneath the reddish dust lies a complex world of rock, minerals, frozen water, and perhaps environments that have remained untouched for billions of years. Scientists believe that underground Mars may be one of the most promising places to search for signs of life. The reason is simple. The surface of Mars is extremely harsh. Radiation from space constantly reaches the ground. Temperatures change dramatically between day and night. Liquid water cannot easily survive. Dust covers everything. But underground, the conditions may be very different. The deeper you travel beneath Mars, the more protected the environment becomes. Layers of rock act like a natural shield. They block radiation. They reduce temperature changes. They create a stable environment compared with the surface. On Earth, some of the oldest and most unusual life forms are found underground. Deep beneath deserts, oceans, and mountains, tiny organisms survive in complete darkness. They do not depend on sunlight. They do not need forests or open skies. Instead, they use chemical energy from rocks and minerals. These discoveries changed how scientists think about where life can exist. For a long time, many people believed life required sunlight. But Earth showed us something different. Life is more adaptable than we imagined. Some organisms survive beneath kilometers of ice. Some live around volcanic vents where temperatures are extreme. Some exist in environments filled with chemicals that would be dangerous to humans. Nature has repeatedly surprised us. So when scientists search for life on Mars, they do not only look for Earth-like environments. They look for places where life could find a different path. One possible location is beneath ancient impact craters. When large asteroids struck Mars billions of years ago, they created enormous amounts of heat. That energy could have melted underground ice temporarily. For a period of time, warm water may have flowed beneath the surface. These hidden underground lakes would have been protected from the harsh conditions above. If microorganisms ever existed on Mars, such environments may have helped them survive. Another possibility involves minerals deep within the crust. Certain rocks can release energy through chemical reactions. On Earth, these reactions support entire ecosystems far away from sunlight. A similar process may have occurred on Mars. Perhaps tiny organisms once lived near underground water and minerals. Perhaps some traces remain today. Or perhaps Mars was always silent. The mystery remains. One of the challenges in searching underground is that Mars is enormous. The planet has a surface area similar to all the continents of Earth combined. Finding evidence of life in such a vast place is like searching for a single grain of sand on an entire beach. Scientists must choose locations carefully. They study satellite images, analyze minerals from orbit, examine data from rovers. Every piece of information helps narrow the search. The landing locations of spacecraft are selected with extreme care. Scientists search for places where ancient water may have existed. Places where organic molecules might have been preserved. Places where rocks can reveal the history of the planet. Every mission is a carefully planned journey into the unknown. Future explorers may use advanced drilling systems to go deeper than ever before. A rover sitting on the surface can only see so much. But a drill reaching beneath the ground could access a completely different world. Imagine a future mission slowly drilling into Martian soil. The machine works patiently. Centimeter by centimeter. Meter by meter. The sample chamber fills with ancient material. Then the instruments begin analyzing what was found. Perhaps the results show ordinary minerals. Perhaps they reveal unexpected chemistry. Or perhaps they uncover evidence that changes everything. A discovery waiting billions of years. The possibility is enough to continue the search. Mars also raises another important question. If life existed there in the past, did it disappear completely? Or did it adapt and move into safer environments? On Earth, life has survived some of the greatest disasters in history. Mass extinctions, climate changes, extreme environmental shifts. Life does not always vanish when conditions become difficult. Sometimes it retreats. Sometimes it transforms. Sometimes it waits. Could something similar have happened on Mars? Could ancient life have moved deeper underground as the surface became colder and drier? Could microscopic organisms still exist in hidden environments today? Scientists cannot answer these questions yet. But they continue searching. Because every mission brings new knowledge. Every experiment removes another layer of uncertainty. Every discovery helps us understand not only Mars, but the possibilities of life throughout the universe. As we leave the imagined underground world and return to the surface, the Martian landscape stretches quietly beneath the fading sunlight. The same dust. The same valleys. The same ancient mountains. But now we understand something important. Mars is not only what we see. It is also what remains hidden. A planet can keep secrets beneath its surface for billions of years. And perhaps the greatest secret of Mars is waiting somewhere deep below. In a place where sunlight has never touched. In a place where time moves slowly. In a place where the universe may have preserved a message from the very beginning of life itself. As the quiet story of Mars continues, we begin to look at another remarkable mystery. The possibility that Mars and Earth were once connected in a way that changed both worlds forever. Not through spacecraft. Not through human exploration. But through rocks traveling silently across space. For billions of years, impacts have shaped the surfaces of planets throughout the solar system. When a large asteroid strikes a planet, the force can be unimaginable. The explosion can throw pieces of rock high into the atmosphere and sometimes send them completely away from the planet. Mars has experienced countless impacts throughout its history. Some of those collisions were powerful enough to launch Martian rocks into space. These pieces of Mars began drifting through the solar system as small travelers carrying secrets from another world. Eventually, some of them reached Earth. Scientists have discovered meteorites on Earth that originated from Mars. These rocks are among the most valuable objects ever studied because they allow researchers to examine pieces of the red planet without traveling there. Inside these ancient stones are clues about Mars chemistry, volcanic history, and environmental changes. Some contain minerals that formed when water interacted with rocks. Others preserve information about the conditions that existed billions of years ago. Each meteorite is like a small messenger from another planet. A message that traveled across unimaginable distances before arriving here. The idea that rocks from Mars reached Earth also raises a fascinating possibility. Could material from Earth have reached Mars? The answer is likely yes. Large impacts on Earth may have sent pieces of our planet into space as well. Some of these fragments could have traveled to Mars. For billions of years, planets have exchanged pieces of themselves. The solar system is not a collection of completely separate worlds. It is a connected neighborhood where materials move between planets. This connection creates an interesting question. Could life, or the ingredients for life, have traveled between worlds? This idea is known as panspermia. It suggests that microorganisms or organic materials could potentially move from one planet to another through space. The concept does not mean that life definitely traveled between Earth and Mars. Scientists have not found proof of this. But the possibility is scientifically interesting because rocks can sometimes provide protection. Inside a meteorite, microorganisms or organic molecules could be shielded from some dangers of space. The journey would still be extremely difficult. Space contains radiation. Temperatures are extreme. The time required could be enormous. But nature has surprised us before. Some organisms on Earth can survive conditions that seem impossible. Certain microscopic life forms can enter a state of deep survival, almost shutting themselves down until conditions improve. This ability reminds scientists that life may be more resilient than we once believed. Mars and Earth have also shared another important connection. They have similar histories during the early formation of the solar system. Both planets formed from the same cloud of dust and gas surrounding the young sun. The same basic ingredients were available. The same cosmic environment shaped them. Yet their paths slowly separated. Earth developed oceans that remained stable. Mars lost much of its atmosphere. Earth maintained a strong magnetic field. Mars gradually lost its protection. Earth became a world filled with complex ecosystems. Mars became a world of ancient memories. Studying this difference helps scientists understand one of the biggest questions in planetary science. Why do some worlds become suitable for life while others do not? The answer may depend on many small factors. A planet's size, its distance from its star, its internal activity, its atmosphere, its magnetic field, its history of impacts. Even tiny differences can create completely different futures. Mars shows us how fragile habitability can be. A planet may have water. It may have chemistry. It may even have the right temperatures for a period of time. But maintaining those conditions over billions of years is another challenge. Life requires not only the right ingredients. It requires stability. This is one reason Earth is so remarkable. Our planet has experienced countless changes throughout its history. Yet conditions remained suitable long enough for life to evolve from simple organisms into the incredible diversity we see today. Mars may have had a shorter window. A time when possibilities existed. A time when rivers flowed and lakes filled its valleys. A time when life may have had a chance. Then the planet changed. The atmosphere became thinner. The surface became colder. The water disappeared. The opportunity may have faded. But the evidence remains. And that evidence is what future explorers hope to find. Every ancient rock could contain information about Mars' lost era. Every mineral could reveal the chemistry of forgotten oceans. Every sample could answer questions that humans have wondered about for centuries. As the sun sets once again over the red planet, the ancient landscape becomes covered in shadows. The rocks remain silent. The valleys remain still. The dust continues moving slowly across the ground. But somewhere in those rocks may be a connection between two worlds. A reminder that Earth and Mars are not strangers. They are neighbors. They share a history written across space. And perhaps one day, by studying Mars, we will discover not only the story of another planet, but a deeper understanding of the story of life itself. As the peaceful journey across Mars continues, we now enter one of the most mysterious chapters of the Red Planet's story. The ancient oceans of Mars. Today, when we look at Mars, we see a dry and dusty world. A planet covered with deserts, mountains, and frozen landscapes. It is difficult to imagine that this same world may once have contained vast rivers, deep lakes, and possibly even enormous oceans. But the evidence hidden across the Martian surface tells a different story. Long ago, Mars was not the silent desert we know today. It was a changing world. A world where water moved across the land. A world where clouds may have filled the sky. A world where ancient landscapes were shaped by flowing rivers. Scientists discovered some of the strongest evidence by studying valleys carved into the surface. These formations look remarkably similar to river channels on Earth. They stretch across the landscape like ancient pathways. Some are hundreds of kilometers long. Others reveal patterns that could only have been created by flowing water. Wind can move dust. Lava can carve valleys. But the shapes found on Mars often tell a different story. A story written by water. Imagine standing beside one of these ancient channels billions of years ago. The sky would look different. The atmosphere would have been thicker. The temperature may have been warmer. Water would move across the landscape, slowly cutting into rock. Small streams would join larger rivers. Rivers would carry minerals and sediments toward lakes and perhaps even oceans. The planet would have looked completely different. It may not have been another Earth, but it may have been a world with many similarities. One of the most fascinating discoveries involves ancient lake beds. Scientists have identified locations where water likely collected for long periods of time. One famous example is Gale Crater. Inside this enormous crater, evidence suggests that a lake once existed. Layer after layer of sediment formed at the bottom. Over time, these layers turned into rock. Those rocks became a record of the environment that existed billions of years ago. By studying them, scientists can learn about ancient water chemistry, climate conditions, and the possibility that life could have survived there. Lakes are especially interesting in the search for life because they provide many important ingredients: water, minerals, energy sources, stable environments. On Earth, lakes have supported countless forms of life. They create places where chemistry can become more complex, where microorganisms can grow, where organic material can become preserved. Could ancient Martian lakes have done the same? Could they have provided a home for the first forms of Martian life? No one knows yet. But the possibility continues to inspire exploration. Another clue comes from minerals found across Mars. Certain minerals only form when water interacts with rocks over long periods. Their presence suggests that water was not just a brief visitor. In some places, it may have existed for thousands or millions of years. That changes everything. A short moment of water is interesting. A stable environment with water over long periods is much more exciting. Because time is one of the most important ingredients for life. Life needs opportunities. It needs moments when chemistry can slowly become more complicated. It needs environments where small changes can accumulate. Ancient Mars may have provided those opportunities. However, scientists are still trying to understand how much water Mars truly had. Was it covered with oceans like Earth? Or did it contain many separate lakes and rivers? How long did these environments last? When did the planet begin losing its water? These questions remain open. Some evidence suggests that Mars once had enough water to cover large regions. Other studies suggest that much of the water may have existed as ice beneath the surface. The truth may include both possibilities. Mars may have experienced different periods throughout its history. Times when water flowed freely. Times when the planet froze. Times when underground reservoirs remained hidden. The climate may have changed again and again. A planet's history is never a single moment. It is a long journey. And Mars has been traveling that journey for more than 4 billion years. One of the most beautiful ideas about ancient Mars is that the planet may still preserve memories of its watery past. A stone beside a crater. A layer of sediment inside a valley. A mineral trapped beneath the dust. Each one is a tiny piece of a much larger story. A story about a planet that once looked very different. A story about possibilities. A story about whether life had enough time to begin. As the imagined ancient ocean slowly fades and we return to modern Mars, the contrast is breathtaking. The same valleys remain. The same mountains stand. But the water is gone. The rivers are silent. The lakes have disappeared. Only the evidence remains. Mars is like an old photograph of a world that no longer exists. A reminder that planets can change dramatically. A reminder that environments are temporary. A reminder that the universe is always moving. And perhaps, hidden inside those ancient rocks, there is still a message from the time when Mars was young. A message waiting to answer humanity's greatest question. Was Mars only a planet with water? Or was it once a planet with life? As the peaceful journey across Mars continues, we begin to explore one of the most mysterious questions surrounding the red planet. Not only whether water existed, not only whether the planet was once warmer, but whether Mars had the right conditions for life to begin. Life is one of the greatest mysteries in the universe. We know it exists on Earth. We know it can adapt to incredible environments. But we still do not fully understand how the first living systems appeared. Mars gives scientists another place to search for answers. A second laboratory. A second world where nature may have followed a different path. The ingredients needed for life are surprisingly simple. Scientists often look for three major requirements. Liquid water. A source of energy. The right chemical building blocks. Mars appears to have had all three at different points in its history. Water flowed across its surface. Volcanoes released heat and gases. Minerals provided complex chemistry. Organic molecules have been detected within Martian rocks. The pieces of the puzzle appear to have existed. But having the ingredients does not guarantee the final result. A kitchen filled with ingredients does not automatically create a meal. They must come together in the right conditions. The same may be true for life. Perhaps Mars had everything necessary. Perhaps it was missing one important factor. Perhaps life began and disappeared. Or perhaps it never started at all. That uncertainty is what makes the search so fascinating. One of the most important places scientists study is the ancient Martian environment. They are not only searching for evidence of organisms. They are searching for evidence of habitability. A place where life could have survived. This difference is extremely important. Finding an ancient lake does not mean life existed there. But it means a possible home existed. Finding minerals created by water does not prove biology. But it shows that chemistry had a chance to develop. Each discovery brings us closer to understanding what Mars was capable of. Another fascinating clue comes from clay minerals. On Earth, clay often forms when water interacts with rocks over long periods. The discovery of clay on Mars suggests that some areas once had stable water environments. Not just temporary floods. Not just brief moments of melting ice. But conditions where water may have remained for extended periods. These environments could have provided peaceful places where complex chemistry developed. Imagine an ancient Martian lake. The water is calm. Minerals slowly dissolve from surrounding rocks. Sunlight reaches the surface. Chemical reactions occur. Tiny changes happen over thousands and millions of years. On Earth, similar environments eventually became connected to the story of life. Could the same have happened on Mars? That question remains unanswered. Another mystery involves the planet's ancient atmosphere. A thicker atmosphere would have changed everything. It could have helped maintain warmer temperatures. It could have allowed more stable water. It could have protected the surface from harmful radiation. Scientists study ancient rocks and minerals to understand how Mars lost its atmosphere. The answer may reveal when the planet changed from a potentially habitable world into the cold desert we see today. Mars also teaches us about time. The planet is incredibly old. More than 4 billion years have passed since it formed. During that enormous period, countless events occurred. Volcanoes erupted. Asteroids collided. Climate changed. Water disappeared. The planet transformed again and again. Any evidence of ancient life would need to survive all of these changes. That makes the search extremely difficult. Imagine trying to find a single message written on a sheet of paper after billions of years of storms, heat, freezing temperatures, and impacts. The fact that any clues may still exist is remarkable. Yet Mars has preserved many of its ancient features. Because the planet lacks active plate tectonics like Earth, old landscapes remain visible. Ancient valleys have not been completely destroyed. Old rocks still sit where they formed. The past remains closer to the surface. In some ways, Mars is a time capsule. A frozen moment from the early solar system. And that is why scientists continue returning. Every mission carries new questions. Every rover becomes another pair of eyes exploring a world humans have never touched. The search for life on Mars is not only about discovering another organism. It is about understanding the possibilities of life itself. If Mars had life, then perhaps the universe creates life easily. If Mars never had life, despite having water and chemistry, then perhaps life requires a rare combination of events. Either answer would be profound. Both possibilities change our understanding of existence. The mystery of Mars reaches far beyond a single planet. It connects to the largest questions humans have ever asked. Why are we here? How did life begin? Is Earth unique? Are there other worlds looking toward the stars and asking the same questions? Mars may not immediately provide all the answers, but it brings us closer. Every rock studied, every image captured, every experiment performed, each one adds another sentence to the story. And slowly, patiently, humanity is learning to read the ancient pages written across the red planet. A planet that once had rivers. A planet that once had lakes. A planet that may have once had everything needed for life. And perhaps, beneath the quiet dust, a planet that still holds one final secret waiting to be discovered. As the quiet story of Mars continues, we now travel deeper into one of the most important mysteries of the red planet. The mystery of its disappearing water. Because when we look at Mars today, one question immediately appears. Where did all the water go? A planet that shows evidence of ancient rivers, lakes, and possibly oceans now appears almost completely dry. The answer is not simple. Mars did not lose its water in one dramatic moment. Instead, the transformation happened slowly over billions of years. A world that once had flowing water gradually became a frozen desert. The story of this change is written in the atmosphere, the rocks, and the hidden ice beneath the surface. One of the biggest reasons Mars lost its water is connected to its atmosphere. A planet's atmosphere acts like a protective blanket. It controls temperature. It helps maintain pressure. It allows certain materials, including water, to remain stable. Earth has a thick atmosphere that helps keep oceans and rivers on the surface. Mars once had a much thicker atmosphere than it does today. But over time, that atmosphere became thinner. As the protective layer weakened, maintaining liquid water became much more difficult. Water on the surface began to disappear. Some froze. Some became trapped underground. Some escaped into space. The process was slow, but the result was enormous. A planet changed forever. Scientists study this transformation because it reveals how delicate planetary environments can be. A world does not need to lose everything instantly to become uninhabitable. Small changes over long periods can completely reshape a planet's future. Mars is a powerful example of this. Another important factor is the planet's size. Mars is much smaller than Earth. Because of its smaller mass, it has weaker gravity. Gravity is important because it helps hold onto an atmosphere. Earth's stronger gravity allows it to keep a thick layer of gases surrounding the planet. Mars, with weaker gravity, had a harder time maintaining its atmosphere over billions of years. The loss of atmosphere created a chain reaction. Less atmosphere meant less protection. Less protection meant more cooling. More cooling meant less liquid water. Less liquid water meant fewer environments where life could survive. One change affected another. The entire planet slowly transformed. However, Mars did not lose all of its water. A significant amount remains hidden. The polar regions contain large deposits of frozen water mixed with other materials. Beneath the surface, enormous amounts of ice may exist. These hidden reserves are one of the most valuable resources for future exploration. Water is not only important for survival. It also provides information. Frozen layers can preserve records of the planet's climate history. Like ancient pages in a book, ice can contain clues about conditions from long ago. Tiny trapped particles, chemical signatures, evidence of atmospheric changes, all preserved inside frozen layers. Future missions may study these deposits to better understand how Mars changed. Perhaps they will reveal exactly when the planet became cold and dry. Perhaps they will reveal periods when conditions became temporarily favorable again. Mars may have experienced many cycles throughout its history. Times of warming. Times of freezing. Times when water moved. Times when it disappeared. The planet's story may be much more complicated than a simple transition from wet to dry. Another fascinating possibility is that some water may still exist underground in liquid form. Scientists are cautious about these ideas because detecting underground liquid water is extremely difficult. The conditions would need to be exactly right. Pressure, temperature, mineral content, all would influence whether water could remain liquid. But if hidden reservoirs exist, they would be among the most exciting places to search for life. A dark underground environment with water and minerals could provide exactly the type of place where microorganisms might survive. The idea is especially interesting because life on Earth has shown incredible adaptability. Deep beneath the ocean floor, inside rocks, near extreme volcanic environments, life has found ways to survive where humans could never live. Mars may have its own hidden survivors, or it may simply contain the chemistry that could have supported life long ago. Either possibility is scientifically valuable. The search for water on Mars also connects to the future of human exploration. Before astronauts can build long-term habitats, they will need reliable resources. Water will be one of the most important. A settlement without water cannot exist. But a settlement near accessible ice could become much more possible. Future explorers may choose landing locations based on water availability. They may build habitats near ancient ice deposits. They may use local resources to create oxygen, fuel, and supplies. In this way, the same water that tells us about Mars' past may also help create its future. A fascinating connection exists between ancient oceans and future explorers. The water that once shaped Martian valleys may one day support human life. A resource from the distant past becoming a tool for the future. As we imagine standing on Mars beneath its quiet sky, the planet feels different. The dry valleys no longer seem empty. They become reminders. The frozen poles are no longer just ice. They become memories. The underground layers are no longer just rock. They become possible hiding places for answers. Mars is not a dead world. It is a world whose history has been carefully preserved. A world that lost much of what it once had. but a world that still carries evidence of its incredible journey. And somewhere within that evidence lies the answer to a question humanity has asked for generations. When Mars had water, did something else appear? Did the chemistry of this ancient world remain only chemistry? Or did those rivers and lakes once carry the first signs of life beyond Earth? The red planet continues waiting. The answer remains hidden. But every discovery brings us closer to the moment when Mars finally reveals its deepest secret. As the journey across Mars continues, we now enter a quieter and deeper mystery. A mystery hidden inside the rocks themselves. Because on Mars, rocks are not just pieces of stone. They are storytellers. They carry memories from billions of years ago. They preserve moments from a time when the planet was young, when volcanoes were active, when rivers flowed, and when the conditions for life may have existed. Every rock on Mars has a history. Some formed from ancient lava. Some were shaped by flowing water. Some were created when powerful impacts changed the landscape forever. By studying these rocks, scientists are able to travel backward through time. They cannot physically return to the ancient Mars of billions of years ago. But the minerals inside these rocks act like records. They reveal what the planet was like when those rocks were formed. Imagine holding a stone that has been sitting silently for more than 3 billion years. Before humans existed. Before dinosaurs walked on Earth. Before many familiar features of our own planet had formed. That single piece of rock could contain information from a completely different era of the universe. It could tell scientists about ancient climates, ancient environments, and perhaps ancient possibilities for life. One of the most fascinating types of rocks on Mars are those shaped by water. When water flows through rocks, it changes them. It dissolves certain minerals. It creates new chemical structures. It leaves behind evidence of its journey. On Earth, scientists use these changes to understand ancient environments. The same method is used on Mars. A rover examining a rock is not simply looking at its appearance. It is studying a message written in chemistry. The colors, the textures, the minerals, the tiny structures inside. All of these details reveal clues. Sometimes the clues are obvious. A mineral that forms only in the presence of water. A pattern created by sediment slowly settling at the bottom of a lake. A chemical signature suggesting a past environment where life could have survived. Other times, the clues are much more difficult to understand. Science often begins with uncertainty. A discovery creates excitement, but also creates new questions. That is the nature of exploring another world. Mars does not provide easy answers. It provides puzzles. And humanity slowly solves them piece by piece. One of the greatest examples of this is the search for biosignatures. A biosignature is a sign that may indicate the presence of life. It could be a chemical pattern, a mineral arrangement, a structure inside a rock, something that is difficult to explain without biology. But scientists must be extremely careful. Nature can create surprising results without life being involved. Certain chemical processes can imitate biological patterns. That means one unusual discovery is never enough. Scientists need multiple lines of evidence. Different instruments. Different experiments. Different explanations. The goal is not to find life at any cost. The goal is to be certain. A confirmed discovery of life beyond Earth would be one of the greatest moments in human history. Because it would answer a question that has followed us for thousands of years. Are we the only living world? The rocks of Mars may eventually provide that answer. Another fascinating part of Martian rocks is their connection to volcanic activity. Mars contains some of the largest volcanoes in the entire solar system. The most famous example is Olympus Mons. This enormous mountain rises far above the surrounding landscape. It is a giant reminder that Mars was once a planet of intense geological activity. Volcanoes played an important role in shaping the atmosphere. They released gases. They created new landscapes. They provided heat and energy. On Earth, volcanic environments are closely connected with life. They create chemical reactions and provide energy sources for microorganisms. Ancient Mars may have had similar environments. Perhaps volcanic regions combined with water to create places where life had opportunities to begin. Perhaps these areas preserved some of the most important clues. This is why scientists carefully study volcanic regions and ancient lava flows. They are not only looking at mountains. They are looking at chapters of planetary history. Mars is a planet where the past remains visible. On Earth, erosion and moving continents constantly rewrite the surface. Old landscapes disappear. Ancient evidence is often buried or destroyed. Mars is different. The planet changes slowly. Its ancient stories remain exposed. A valley carved billions of years ago may still exist. A rock formed during the planet's early history may still sit near the surface. A crater created by an ancient impact may still preserve its original shape. Mars protects its memories. As future missions explore more areas, scientists hope to collect even more pieces of this ancient puzzle. Perhaps one day, samples returned from Mars will reveal details that no rover could discover alone. Inside carefully protected laboratories on Earth, scientists will examine these rocks with the most advanced instruments ever created. They will search for chemical signatures. They will study microscopic structures. They will compare Martian materials with Earth's oldest rocks. And perhaps they will finally discover whether Mars ever crossed the mysterious boundary between chemistry and life. For now, the red planet remains quiet. The winds continue moving dust across ancient plains. The mountains continue standing beneath the pale sky. The rocks continue waiting. They have waited through billions of years. They have witnessed oceans disappear. They have watched volcanoes fade. They have seen the solar system transform. And now, after all this time, they are finally being heard. Because every stone on Mars carries a story. And perhaps one of those stories may reveal the greatest discovery humanity has ever made. And so, our journey across the silent world of Mars comes to an end. A planet that once carried rivers, lakes, and ancient mysteries still holds countless secrets beneath its red dust. We explored its mountains, its valleys, its frozen oceans, and the hidden possibilities beneath its surface. Mars has shown us that even a quiet and distant world can tell an incredible story. The question of life on Mars remains unanswered, but the search continues. Every rock, every discovery, and every mission brings humanity closer to understanding the truth. Perhaps Mars once had life billions of years ago. Perhaps hidden beneath the surface, something still waits to be discovered. Or perhaps Mars teaches us something even greater about the rarity and beauty of life itself. Looking back at Earth from Mars reminds us how precious our own planet truly is. A small blue world carrying every human dream, memory, and story. The exploration of Mars is not only a journey to another planet. It is a journey to understand where we came from and where we may go next. So tonight, As you close your eyes, remember that the universe is still full of wonders waiting to be explored. Good night, and let your dreams travel beyond the stars.